Okay, so uh, good evening, everyone. And as some of you, of course, I'm sure who are on the line noticed that this is a bit unusual timing because Ajay ji, of course, come from the other side of the globe. And hence this required a special timing. So we are here and ASSET, for those of you joining from outside, it stands for Advances Science, Engineering and Technology. And today's talk on India's quest for indigenous supercomputers, of course, fits very well on the technology areas of the ASSET. And Ajay ji is, of course, is a veteran in this field, and he's going to take us through this journey. But before he actually starts his colloquium, I would like to request one of my very senior colleague, Professor Vivek Datar, to formally introduce today's speaker, and then we go into listen to Ajay ji.
Okay, thank you, Satya. Thank you, Ajay, for agreeing to give this talk. So let me first give a very brief introduction. Dr. Ajay Mohanty got his PhD from the University of Maryland at College Park, and then after that he was a very well recognized, internationally recognized technology executive, working in IBM initially, I think for something like 25 plus years, and then at Deloitte, and so in all he has been around in these capacities as executive for maybe 30-35 years. He has played a leading role in with these private and public partnerships, scientific research, education, and so on in the generally the information technology sector. He is author of about 35 or more research papers, has several US patents. He has received many awards, including the highest corporate award, which is the IBM CEO Award and Senior VP Award, IBM Invention Achievement Award, the Deloitte Outstanding Performance Award for Excellence in Research, Management and Delivery. He has helped numerous research projects between IBM and leading institutes in many countries, US, UK, and other countries like China, Japan, and India. He has advised and consulted the Department of Science and Technology, the Department of Atomic Energy, MITI, the Government of India, and of course the PMO and the NITI Aayog on India's mega science projects, National Supercomputing Mission, and Digital India. He has received the Global NRI Award at the hands of the late President Pranab Mukherjee for Information Technology in 2017. So now may I request Dr. Ajay Mohanty to give his talk on India's quest for indigenous supercomputers and aspirational journey. Dr. Ajay Mohanty.
Thank you, Professor Datar. Thank you, Satyanarayan ji, for inviting me to give this talk. Am I audible clearly?
Yes.
Okay. I was in TFR last year in February, and I was asked to give a talk there, but in fact, because of COVID, I was trying to hurriedly get out of the country, so I did not want to stay any longer, and the airports were being audited, and people were being checked. So I left actually, and could not stay 1 or 2 days more to give a talk. And later on, when Professor Datar and Satyanarayan ji approached me, I said, I'll be delighted to. TFR actually holds a very august position in the development of supercomputers in India. I'll get into that a little bit. And I would have very much liked to meet the audience there, today, of course, because of certain conflicts, so not so many people could join, but I'll be very happy to give a follow-on Satyanarayan ji afterwards. There are many other topics in the supercomputer technology and also applications, which will be of interest to multiple institutions that you are involved with.
Thank you.
Why is I'm not getting to go to the next one. Okay. Can everybody see this?
Yes,
Yes,
yes.
yes.
Okay. The leadership in high performance computing is indispensable to a country's industrial competitiveness, national security, and potential for scientific discovery. Yet heightened global competition places India's leadership under a threat and scrutiny. So this is actually what I wrote very recently to the Prime Minister's office. Unfortunately, the state of the affair is such that we have been in the middle of many election cycles. And let me go a little more detail into what has happened, how India has progressed in the last 5 years in this journey. When we see, this is a very crucial statement because when it comes to national security applications, you cannot compromise. And India cannot afford to, have dependency on the foreign supercomputers. Those of you who may know, it takes about 7 years, say, for a supercomputer to be approved by United States. Say the computers Mihir and Pratyush, which is used at IITM Pune, it took about 5 years to get it cleared. So by the time actually you get a computer, it is already obsolete, number one. Number two, then you have to really go through completely, sign your life in blood, in those letters, just to get the computer back to the country. Because I have been witnessed that in many years of my life, because I did work on various computing bits that went to India, including the very first supercomputer to Indian Social Science Bangalore. Let me begin with, this is the defense review from New Delhi in 2019. There hasn't been many reviews from Delhi coming out. If you read this, India began its supercomputing journey with the param in 1980s. After the United States banned the export of Cray supercomputers. And in 2008, ECA from Tata's Computational Research Laboratories was ranked 4th among global high-power supercomputing systems. This was a time when both India and China had only a handful of supercomputing systems that could make it to the top 500 list. Since then, however, their respective supercomputing stories have diverged significantly. While in India, benign neglect of HP sector has led to plundering of the nascent ecosystem, China has made furious progress and its indigenously developed supercomputers now rank among the fastest in the world. So as one of the top computer experts in our country, Vijay Vatkar, the father of supercomputing in India, once had said, great nations are not built on borrowed technology. Let me tell you why there was a nascent ecosystem in India in the late 90s. I used to visit India quite often because I was assigned to Southeast Asia for the research and the high performance computing division for 5 years. There was Anupam from BARC. There was, I forget the name, from Tata Institute. Indian Institute of Science, Uday Sinha had a system. And of course, SIDAC had param. And there were a couple of more, but they were all trying to build this prototype system, which can be used to solve the weather problem in India, because the monsoon prediction is a huge problem. And that is what they were trying. And the param was developed in 1990s. You can see from 1991 onwards. And param 1 to 800, param 10,000, paramPadma. Actually, paramPadma, this is the list you can see. paramPadma came during HPC Asia when I was actually attending the conference in Bangalore. HPC Asia was the first time it was hosted in Bangalore in India. Prior to that, it was in Tokyo and Taipei. And we actually worked very hard to bring it and showcase paramPadma. They all, the HPC Asia participants went to see paramPadma being demoed in Bangalore CDAC office. And we all went to see that, and we were very thrilled. There was one petaflop machine, okay? And of course, it used the IBM processor. So that is not an issue at all, using different kind of processor, because most countries, even China at that time, did not build the processor. Actually, China came 10 years later. So now you see, in the last 10 years or so, we have several param system, but significant among them, you can see the paramSivaya started in 2019. It was demoed, actually not installed in Banaras Hindu University. But I'll tell you something little bit about BHU. We were in HIPC conference in Jaipur in 2018 December, and we heard that the CDAC is going to unveil the indigenous supercomputer in Banaras Hindu University. I didn't understand why Banaras Hindu University, IIT, but there was definitely a reason why Modi wanted to go and unveil that. And because there was the election time, and Banaras was the place from where I believe he was actually contesting from. And very happy to know that the announcement came during the conference. And but unfortunately, I couldn't. I went to the NRI conference to which we were invited. And this paramSivaya was, I'm giving you this little bit of the history because to show, how much we have really precipitously fallen in the computer ranking and where we stand now. As a nation, we must ask these questions, when we try to develop our next generation of supercomputer. So on February 19th, Prime Minister Modi unveiled this paramSivaya supercomputer. You can Google and see the picture and everything, okay? So by that time, I had left actually after attending the NRI convention because I could not stay in Delhi. I wanted to stay in Delhi for the INO. You remember, Professor Dattar, at that time, INO was, we were struggling with INO, and then I really wanted to stay for a few days in Delhi, but my health didn't permit, and the pollution was the worst during that time in Delhi. So I left Delhi, and suddenly I actually got the messages from my industry colleagues from Intel and IBM and others that this was unveiled and in BHU. But paramSivaya is anything but an indigenous system, which is neither supports the role of Make in India or Digital India. They are wholly imported or assembled from imported components. In fact, IIT BHU installed paramSivaya supercomputer that was actually made in France. So that is the Atos or Bull Sequana computer which was installed, and it was simply purchased from the French government. So here is the key. I mean, I have put this in red. This is how the after the computer was installed, so there was a retracted news information from India Tech Online. So it's character statement. You can read it in red. They said that we erroneously reported that it was indigenously developed. Our interpretation of this machine was in fact flowed from the following statement. It had a misleading statement which says it was designed and built by CDAC. Okay. So they had to retract these statements. So it meant it was an indigenous development. Wrongly, they had assumed it. So the machine does, unveiled by the Prime Minister 2 days ago, would appear to be a Bull Sequana computer. So the paramSivaya and the, let me just go back and show you paramSivaya, paramBrahma in 2019. and paramSiddhi, the latest machine that CDAC has, supposedly built or assembled together. It's on the fifth. I think it is 89th largest computer in the world. Hello? Yes?
Oh, you can go ahead, Ajay.
So it is indeed an Atos or a French-built computer. Okay. So how did he fall so far from the glory days in 2008? In 2008, what we heard, you see, this is the announcement on October 2007. Okay, it was an astonishing achievement. It was led by Narendra Karmakar, who worked at TIFR at some point, and they moved to Tata CRL and built with $30 million, roughly 180 crores during that time. And it ranked fourth in the world. Fourth in the world. The Blue Gene IBM computer was the number one. And China and Japan were nowhere in the top four. Okay. So India had the fastest machine in Asia. They built this in 6 to 8 months, I believe, and actually the computer was benchmarked in the last 40 days or so in record time. And the brilliant achievement by Narendra Karmakar was to design the algorithm for the network architecture and also the algorithm by which the communication can take place. That's his genius. Okay, I mean he was simply the best in the world, so to say. And India actually took advantage of his expertise to build this supercomputer in record time and came out the fastest in Asia Pacific. And it cost about 180 crores. But I think the power consumption was very, very, very big, huge compared to the 172 teraflop. But that needed to be worked on. Okay, but we could not really take advantage of this opportunity to build the ecosystem. Go ahead and take advantage of the opportunity that we have a system which is the fastest in the world, and start building the applications on top of that, optimizing that. Okay, let me go how the countries have invested over the years. I will tell you what China has done better and what Japan has done better and what we could have done actually better, and reflect on that and propose a plan for next 4 or 5 years how India can come up to that rank. Okay. So United States, this National Strategic Computing Initiative, many of you have heard, may have heard that was announced by Obama in 2015, 320 million per year. That would be roughly $1 billion plus $1.5 billion in over 5 years. China, similarly, 200 million per year for 5 years. That's close to $1 billion. So every country, Japan also about $1 billion. Okay, and European Union was going to spend 1.1 billion. India was going to spend about 700 million in those 215. I think it was 4,500 crores. So 140 million per year. So 700 million roughly. South Korea, 20 million there. Russia, of course, not applicable. We don't know how much money they were going to spend, but they announced a few other things. Even the Russians actually went by seeing this much of money India going to be spending. They went to India and asked for collaboration. I remember writing this letter to PMO saying that there should be no collaboration with Russia whatsoever. That's not a thing they should consider. Fortunately, nothing happened. No collaboration took place. So this was the investment that was done 5 years ago. Keeping that in mind, let's see the result first. Okay, let me go to this slide first. This is the last June 2021 numbers in the top 500. You see, China has 188 systems, which are all indigenous processors, and their own supercomputers in China and in other parts of the world also they have installed. In fact, Ireland has 4 or 5 of them in their country. US 122, Japan 34, and if you combine all the European countries, including Ireland, Germany, France, they are roughly about 90. So between themselves, you can see the investment has actually worked very well for them. The US is second leading country, and China is the leader in number of supercomputers, but Japan is at the top, and I will come to that in a minute. And India is actually 3 of them, but they're all imported. I think nothing, after 5 years of effort, actually 7 years, 14 they announced, but 15 they started giving the money. I know exactly when the money had flown from the cabinet secretary to other departments, because I was constantly in touch because of the Digital India program. So you see the result which comes out, they delivered. Japan delivered, US delivered, US is about to install exaflop systems, 2 of them in Oak Ridge, and China also delivered, okay. But we didn't. Just look at this. This is the number 89 in India's rank. 107 is the Pratyush and Mihir. I talked about the weather systems in IITM and NCMRWF. So many years ago when we were actually, I was going to India very often to work with IISc. We actually tried to sell them a system, IBM SP2, and Professor Balakrishna was the director of SARC then. It was quite a tough battle, but that actually was meant for weather, optimizing the weather in IISc so that we can demonstrate to the Indian Meteorological Department that they can be parallelized. Small system, but that was a prototype that could be sold to India in the very first supercomputer. And we were also responsible for the joint program with IISc on the weather system. Okay, I'm in IBM's first shared university joint program. So these 3 systems, they are all imported and nothing indigenous developed. Okay, after 7 years almost of being announcement and NSM announcement. So here is the top system in the world, top 10 last year, this June 2021, not last year. In 2020 also they remain same. Let me say just a few words, you can read it to yourself. Then supercomputer Fugatu is named after the Fujitsu mountain. It's a different name, separate, completely different name for Fujitsu mountain. It has, you can look at 442 petaflop, okay? That is the peak computer on all 4 categories that, the HP AI, in terms of artificial intelligence computing, single and double precision, and machine learning, and the LINPACK benchmark number top 500, and HPCG, they are calling it conjugate gradient metric, which is measuring the production worthiness of the machine. And the green computer, that means power consumption. All 4 Japanese computer Fugatu actually excelled, and it's the number 1 in the world. All 4 metrics. So it's at 442 petaflop in the R marks, and the good thing is that in the AI it actually exceeded something like 2 exaflop. So this is the first claimed exaflop machine in the world this year. And it was actually originally built, it took 7 years to build, about $1.2 billion. That's what they spent, mostly on this system, bit by Fujitsu and Riken joint collaboration. Many years ago, when I used to visit Japan, the Japanese general manager Actually, he was on the education general manager, but he was in charge of the HPC. So he would take me around in the night for a drink, and he will see this Fujitsu sign blinking, the neon sign. So I asked him actually casually once, what really bothers him at night, and I thought that he will think about some physics problem or some bid in Kyoto University or somewhere. He said this Fujitsu neon sign blinking actually causes me the heartburn. So now he's probably getting much more heartburn because the Fujitsu, in fact, the K computer was running supreme at that time. And this is a monstrous machine which can solve many problems. That was unthinkable. If I have time, I'll show you, how they have simulated the COVID spreading of COVID in the latest supercomputer and Fugatu. So the other one, the China one is Sunway Taiyu Light. So this was actually running supreme for 5 years as the number one, and indigenously built with their own processor and collaboration between National Supercomputing Center in China. That is, but the new entrance is also from NORSC, from Perimeter. That is from NORSC, Lawrence Berkeley Laboratory. And the China has the other one, Tinai 2A. So these are the two from China, and mostly 4 from US, and 1 from Italy, and actually 5 from US. So you can see this number 10, Frontera. This is at Texas Advanced Computing Center, University of Texas at Austin. One of the supercomputers actually engaged in the LIGO program, because they are the ones who are doing the most of the computer simulation of those black holes merging. So the contribution of this one, I'll try to show if I get time. So here is the performance development. You can see for n is equal to 500 how many fold performance improvement has happened over the last 30 years or so. Now it's at 442 petaflop. That is for the Fugaku, and you can see the growth, phenomenal growth in the performance development in the last 25 years. So this is the HPCG, that means conjugate gradient metric, by which they judge. Riken, the Fugaku machine is still running number 1 in that. It is something of, I would say, ingenuity of Japanese engineers and scientists to devise this one, which can excel in power consumption, in conjugate, the production worthiness, AI machine, and also the impact number. That's unbelievable, actually. That is something to be marveled at, actually. It has never happened in supercomputing history. Now, let me try this YouTube to show you if this works.
Wow, look at this. 94% of people believe company culture is important to an organization.
So this is the colliding black hole simulation in the Texas supercomputer in Texas, Austin. You can see that.
We cannot see the video that you are playing.
I think it is running on another screen, it seems to be.
Yeah, so
if you can stop this for temporarily if you like, and then
on share, then share the entire screen rather than the PowerPoint.
That's right.
How do I do that?
Share the screen again.
Desktop.
You can share screen, and then it will tell you, you can click on the entire No.
No, this is only the PowerPoint.
This is only the PowerPoint.
Yeah.
Yeah. So
Click on this one.
You can unshare, Ajay.
Huh?
You unshare it first. Stop sharing.
Yeah.
No,
and then share the entire screen.
you are still sharing it. Can you stop sharing? Now go to share screen.
Yes.
And on the top left, there will be, screen. Yeah, I think if you see on the top left, something marked as screen. Can you see?
View stream on custom live streaming service.
No.
Same. Share screen only.
Share the entire screen.
You click on the, that green color share screen upward arrow at the bottom of the screen.
Yeah, I did it then.
Okay. Then did it open something?
Yeah.
On the top left of that screen, can you see something written as screen?
Yes.
Okay, that is the one you should share. But before that, oops.
Yeah, now
Yeah.
this.
Can you run it?
Click on the.
Why is that noise? You can see it?
Yeah, we can see.
We can see it, yes.
See, these were the two black holes, 30 times sun. I think I can play it again, which was originally in SXX project. I think you must have all seen this during when the two black holes collided. But I wanted to show something else from the Texas Austin.
Something, another sound coming from you. If there any other window running, can you close? Yeah, now there is no noise. No, it is again coming.
It stopped?
Yes, now it stopped. Ajay, are you speaking?
I think something happened.
Okay, can you share it again? The screen now, your usual PPT. You want to go to PPT, right?
Yeah, but
See the PowerPoint. Now go to full screen and go to. No, you have gone too far.
Right here.
Yeah.
Okay. I wanted to show you the other one, but I think I'm having a problem. There is another one on the supercomputer Fugatu, which actually simulates the spread of COVID when people are coming and they are not sitting too far, that I can show. But let me just go to say something about the China supercomputing strategy. So we actually, there was a conference in 2016 in Hyderabad, and Dipei Qian, who is the leader of supercomputing in China, had come. And during the discussion, actually, I asked him several questions and we got a little more friendly. what he was really trying to do, he actually at that time, the China's, Taihu Light Sunway had come out to be the #1 supercomputer with 94 petaflop. And they wanted to showcase that, and he had come to India actually to present. He was the keynote speaker. So at that point, we asked him. Actually, I asked him, what led you to get this kind of funding, 1 odd billion dollars, and also to march ahead with this 5 years of effort to build this supercomputer in China? He said, I went to meet this person, Jinping, and then told him, whispered him that a superpower needs a supercomputer. And he was granted anything that he's asking for. So this is a very powerful statement that he made, during the conference, that a superpower needs a supercomputer. So that actually relates to the vital importance of national security for our country. So these 3 prototypes that they are going to put in Sugan, these in collaboration with the computer, the companies in China, the exaflop is soon to be installed. In fact, in June 2021 conference from Germany, he was giving very last minute to announce whether the exaflop is being installed in China or not, but they didn't succeed. Okay. So such is the importance of this person who has the ear of GP. All 3 Chinese exaflop machines will be self-controlled. That means they are internally supplied Chinese chips and not foreign made. So they control their own destiny. And actually, my recommendation to India is to actually lure some chip companies, if they can, to build chip factories in India, provide enough incentives. If TSMC or Intel or Samsung, they won't come, then India should do it here, do it yourself, because that is what the option is left. It's like the Maurice Chang who built this TSMC in Taiwan. There has to be, India has more investors than any company trying to build. And I think, they are in the process of bidding now. The most important thing, I'm going to come to this, what is the path forward, is the public-private partnership. Why we have not been very successful? You see, you saw ECA model, was money funded by Tata Sons, and then the KFR folks also worked, and the computer scientists coming from all over India, they worked together for 9 months and put together a fantastic machine. Okay, it has lots of other deficiencies, but they could have been corrected. And but we simply splintered. Everybody went in their own direction, and nothing happened after that. So we lost a golden chance by not pushing forward and investing in it. The government simply wears a famous hat now, Make in India, but it tells private industries, you stay away. Because they don't invest in any private industry, whether it is TCS or Wipro or HCL, our indigenous computer companies, they do not invest at all. In fact, I'll tell you this, that Atos computer at the Bull Susquehanna that we are buying, the motherboards were put together by Wipro. When the current IT secretary visited Wipro a couple of years ago, and he heard about it, actually he asked me to write to him about it, why. He simply did not know that Bull had actually contracted Wipro for that. So think about this way, that we are building the machine that is being sold by France to India. So that is what the sorry state of affairs is. The industry, academia, and government nationals must get together in a multidisciplinary approach. Build the ecosystem HPC where the vendors often have a relationship with their customer. This is a crucial point because let me just define what happens. In US, in the Department of Atomic Energy or Department of Space, they work with the computer companies and they design computer based on the application requirement. You don't go other way around. You just build whatever, and then you ask the government labs to build it. Let's take the example of this exascale computer Summit and Sierra that's going to be installed soon. So the Oak Ridge National Lab or Lawrence Berkeley Lab or the Lawrence Livermore Lab, they will work with computer companies like IBM or Cray or Intel or NVIDIA, and they build the machine together, and it's benchmarked by the national labs, and it's a 60-40 share in the sense that 60% of money comes from the government and the industry has a 40% stake. So that is how they build the machine and they benchmark it, but it's overseeing capacity or authority rests with the exascale board, which is an external board. Okay? So the industry doesn't have much say in that. How do they, say that okay, machine actually passed the muster, and also, made the performance. That is done by a completely external board. Actually, ECP board is actually led by a professor of computer science at Caltech. So the whole thing is it's giving independence to the system, but having an centralized system like Niti Aayog will oversee everything on the HPC or technical advisory committee, and they have the final say. That doesn't work, and it hasn't worked. As you can see, that we have zero indigenous system in the entire 500. And the only thing we have done is borrowed it from France and put a stamp there and sold it. So the big advantages, of having companies participate is because you have to give them some incentive. You see, for example, in countries like UK or Germany or Ireland, or even in US, the big companies also can buy $20 million machine, $40 million machine, just to do their own research, the drug companies for their drug research, or the national laboratories. And many software companies, they don't want to give their names, but they also can buy huge machines for their own research. So you have to be able to solve certain problems for the companies to do that. One such problem, which is my own field of research, this is a heavy element catalysis using nanoscale precision. You simulate the surface chemical reaction of heavy elements, on certain kind of molecules, and then design the catalyst. The catalyst reaction simulation is a huge grand challenge problem, and this is going to be worked between many countries, and it will need exaflop calculations, because you can think of the repercussions of using a new kind of catalysis, which will increase the growth, the output production of oil by simply 1%. Even if you increase the output by 1 more percent, it will be like trillions of dollars to the world economy, because US alone consumes 850 billion barrels of gasoline, and gasoline is at $70 per barrel right now, and that probably a 5% improvement in production. I don't know if any one of you know. Many of you should know that 50% of the crude oil, that is wasted. You cannot extract 50%, only extract 50%. So slightly above 2 or 3 or 4, 5% will bring trillions of dollars to world economy. It is crucial for the independence of India, because India almost is consuming 1/3 of the world's resources now. China was also similar, and the US, very similar. So, but India doesn't have its own oil. It refines most of the oil, crude oil, imports it and then refines it. So it's a huge boost to the India if you can provide a solution to that. In fact, last year before I visited TFR, I think after I visited TFR, I had gone to Reliance headquarters to give a presentation on this, and wanted to have a collaboration established between 3 or 4 different countries or the research units. 3, 4 different. No single country can do. Just like the other mega science projects, where many countries have to be involved to solve a problem like this. It needs international collaboration. So, in short, we have not come to the grips of how to solve our supercomputing problem in the last 7 years. After the budget of 4,500 crores, 7 years spent, we're still buying it. In fact, the last defense review said China is killing it when India is importing it. But I really don't want to end this with a pessimistic note. It doesn't mean the supercomputer is everything in the world there to solve many of the problems. Yes, it is needed. This reminds me of a story, actually, not story, my own experience I had gone to Oxford to give a talk on thallium fluoride molecule. And many of you are experimentalists. So the dipole moment calculation of thallium fluoride molecule is very, very important. And it is the experiments are still being done to put some bounds on the dipole moment at Oxford and Harvard and Max Planck in many places. So we wanted to find a bound for the dipole moment from theoretical perspective. So we had largest supercomputer, Blue Gene at that time, and I did the simulation. My group did the simulation. I thought that I have the best result. So we went to Oxford, and before I actually presented, there was a professor from Leningrad. I think his name was Susko. He's in Australia right now. He presented the results, and I saw that, and they don't have any supercomputer at that time. So it is 2005, I think. So I asked Susko, how did you do the simulation? And his result was fantastic. Actually, he had the best bound on the dipole moment. So he said, well, we did the calculation in a PC. So I was astounded, and I fell down from my chair. He did this in a PC. How long does it take to do one iteration for the thallium fluoride molecule? He says about a month. I said it takes about a few hours on our supercomputer, and I did so many iterations, and I got this result. Actually, I was the next one to present. And then I asked him, what do you do in between that 1 month? He says, we think. So the best computer is actually in our brain. We have to think before even we program. But computer is just like a tool. Like you saw that the 2 black holes merging. In fact, I went to University of Maryland. Barry Barris was there, the program manager for the LIGO, and all other 2 Nobel laureates, including Kip Thorne and others, they had come. Maryland is a big hub for gravitational waves, and the Professor Weber, he was the first experimentalist trying to find gravitational waves. They came to pay respect. And during that time, I did not know this, but black holes were never discovered. They were computationally discovered, so to say. They matched the spectrum of the gravitational wave coming from the merging of the black hole. with the supercomputer simulation. And lots of experiments are going on the computer, through the computer, to predict other black holes, and also the LIGO experiments to LIGO India. They will be verifying those black holes' existence later on. So continuously, but incidentally, the simulation that I was trying to show you, it took 24,000 hours on the Texas supercomputer, which is the 10th largest supercomputer in the world. So 24,000 hours of time to do that kind of simulation. So it doesn't mean this is the first time probably a beautiful experiment was in fact validated through the computer simulation. So not all is lost, and I do hope that our country will wake up, and we have brilliant scientists, those who have worked very hard to deliver these supercomputers in the past, and we just have to have the right system put in place. So thank you very much for your attention. Satyaji.
Hello.
That's the end of my talk.
Yeah. Just plus Datar, you want to say something? Otherwise, there is a question from.
First of all, of course, I should thank Ajay for a nice overview of all the computational systems and what we need to do. Could I ask the first question to you?
Sure, please.
Okay. How do we go about setting up not a system, I should say, a factory or something for making these chips, CPUs and whatever other ancillary chips that are needed to make such computers?
Yeah, the thing is that I mentioned.
What is the cost involved, let's say?
It's about $10 billion, okay? About $10 billion. But India is ready to put, say, $1 billion cash to anybody who wants to set it up. Okay, right now, incentive is also close to 25%. Even then, no one is coming. I mean, the Foxconn, the investors are all there. I mean, all over the place. They want to, bring these chip factories, and they can spend the money. But the India's poor record of, the governance and then the compliance and also the regulations, these are bigger problems. So they want to shy away from it. See, for example, Europe wants to, or the US actually is going to set up a factory in Arizona very soon. So combined incentive from Europe and US is like $600 billion. So why would TSMC or Samsung or Intel care about India right now? They would not. And India's total the manufacturing in the chips sector is, the investment, the market is $21 billion compared to $600 or $700 billion worldwide. So that is less than 1%, okay? So not less than 3%, less than 3 or 4%. So it is a very small market. You don't have the market size to attract them. So that is why there is a beautiful article, which I'll send it to you, and recently has published. That's why India may have to do it on its own, because then first we do the servicing of the fab. We do all kinds of servicing and also build the smaller components, and finally it will come. Because India has right now about 900 million cell phones, 900 million cell phones, but the market is controlled by China. See, all these numbers is in my mind because I'm always thinking of competition against China. Okay? So if you have 900 million cell phones, but you don't build anything, we cannot build a cell phone in India. Okay. So that is a tragedy, because that is where we lost to China, because the manufacturing during the 90s and early 2000, we gave it away to China. we thought that we can lead in the services sector. Okay, so that is when IT sector grew in India. Infosys, HCL, Wipro, they grew rapidly in India, and India has gained actually. India's IT sector is one of the best in the world, and they actually perfected it. And we get about $200 billion worth of revenue from IT. That is the second largest industry compared to agriculture. Because if you think of what was $2.7 trillion, the total budget of India, GDP of India, that's $200 billion plus. That's like 10%, coming from IT sector, which is a terrific thing. But we lost in the manufacturing sector by focusing more on the services.
Just one question to you. Maybe you know more about it, but we have just heard recently that the Tata group of companies is thinking of getting into the chip manufacturing sector.
Yeah, I think they somebody has to bite the bullet in the beginning, okay, and I do hope that they get in, but the thing is that I was having discussion with Professor Durga Mishra. I mean, having the oxidation elements, the elements that will clean the air inside the chip chamber, etc. Those are very challenging issues in India because of the pollution and other the scarcity of many elements. So, but if Tata wants to bite the bullet, that is the best thing that can happen, because sometimes you have to actually take a loss, take a big hit, because in the interest of the country, and the market will just simply grow phenomenally because after this, right? It's not the supercomputer, but everyone will have a computer, okay? And India is in a perfect position to leapfrog. I mean, sometimes we actually, I am super critical of India's development because I know just too much. I have more information, in many ways, because I actually present it to the government in many ways. So, but at the same time, India has done phenomenal progress in digital India sector, okay? Better than most countries. But if we, get our act together, there is the chip factory is not the problem. You see, for building the supercomputers, what China did was continuously they got the processor. Until 2015, the processor was being given to China. So the Intel stopped selling, Xenon processor in 2015. So until 2015, they started building, and they started, perfecting their application. They started perfecting their connectivity and the architecture. So by the time, in 10 years they were ready, they were already building their processors. So bye-bye US. Okay, so we don't have to, we missed that because we could have any processor, just like the ECA built it on HP processor, right? So HP processor, HP interconnect, and all we did, the Karmakar's brilliance was that he knew the algorithm which will make the fastest connectivity between the processor and also the cable connection between the interconnect and the processors. That's not simple. So we could have capitalized on that, but we didn't. The chip is really not the issue, but all of us working together. This is why, before I came, I think I mentioned to you and Satyaji and others, I could have met other people, that KFR also in some ways can take the lead. BARC can take the lead. BARC has excellent computer scientists, IISc, but they all have to come together to work with the industry. No, bye-bye industry. Bye-bye industry. See, the reason is that industry will give their heart out because they want to make some money, right? If SIDAC fails to, build a machine, so what? They have a job tomorrow. So that is what works in the capitalistic system, that we have to produce something which is useful. And of course, China has a whip, but India doesn't have a whip. So that doesn't work for us.
Ajay
So
ji,
it will only work. Huh? Yes.
you were mentioning about BRC, and there was a question from YouTube. What is the role of Baba Atomic Research Center in the development of indigenous supercomputers for our country?
Well, that was Anupam. If you remember, I don't know if you remember this, but Anupam was established in 1990s, late 1990s, and they had built a prototype system. But you see, there is a difference between prototype and the production worthiness. So, they never succeeded in building a supercomputer which will solve the problem like weather. CDAC never did. Otherwise, they would not have bought the supercomputer from IBM or Cray. Why would they? If CDAC param could solve the weather problem, why would they buy this? So but they had built that ecosystem where they can contribute and work together. I mean, at that point, there are 4 or 5 groups. I was suckling between BAC and IISc and CDAC, and I think there was another one, ISRO. So Saga was computing, but they didn't succeed. But they have brilliant computer science. Some of them have retired now, so they are not there. But right now, I don't know who are the computer scientists in BAC, but they had a history and legacy of building supercomputers, the first few supercomputers in India. Okay.
There was a discussion with you and Professor Datar just now, and it is a sheer coincidence that something popped up on my screen just as you are discussing. This is a news item that says a team of researchers at IIT-B led by Professor Udayan Ganguly, along with SCL, that is Semiconductor Complex, have successfully demonstrated a CMOS 180 nanometer 8-bit memory technology. This technology is supported by the DST's Advanced Manufacturing Program, is being adopted for production. Of course, this is just a news item that just popped. But what I really wanted to kind of comment is that SCL, which is now, of course, run by Department of Space, is going through, may not be, of course, not in the front-ranking foundries in the world, but it's slowly progressing. I think there are already at least some of the users, including some of those from science applications, using their chips. And IIT Bombay in particular is working hand in hand with them to develop, let us say, the foundry libraries, the technology libraries, I think they're called, and so on. So that way, I think there is a well-established program with IIT Bombay and SCL. So 180 meters of course, nanometers of course, is nowhere near the top of the line. But the fact that it is at least making something useful for, as I said, both for science and also for other applications. I hope, like what you mentioned, and I think Professor Datar also.
No, this is actually news. I remember a couple of years ago, IIT Madras also had something like Sankhya. I forget the name of the chip that they discovered. But those have to be commoditized. What I mean is that first, of course, you have to benchmark them, and 180 nanometer is far from what they are trying to achieve now, 3 to 5 nanometers.
That is true. That is true.
But that's a step in the right direction. And our country, the entrepreneurship, which can go up to say 5 crores of money for each company or entrepreneur to provide ample support. 3-4 companies, they combine together, they can start doing the research. And if Tata comes back to their rescue, or other companies come to their rescue. Actually, I had met Narayan Murthy, I think 2 years ago in Bangalore, and also again next in Jaipur. He came for some talk, and I actually pleaded that he should provide that kind of leadership and have a discussion with the Prime Minister, in how we can lead in this effort, because we are not, the institutes cannot do much in this. I think there has to be intervention from very high level. Okay, so in fact, we went and pleaded with him, but not much has happened. These directions have to come from. It's more centralized. In my understanding, is the power structure is more centralized. Comes from Prime Minister. You know this from I know how it works. Okay, so there has to be changes, or change in thinking from the top.
Yeah.
So I mean, every country has, what I was trying to say, that every country has its own peculiarity. I have been very fortunate to go to Japan, very fortunate to go to China in the early days when there was supercomputing developments. I've experienced them. We were competing with them, and China and Japan, and also in the middle of US. IBM is actually in the thick of things here. So that gives me some kind of exposure to talk about this at length. And the frustration arises that India has everything but still cannot achieve.
Yes, I agree. And so, are there any further questions on the YouTube or on the Zoom?
Yeah, I can just make a comment about that thing that IIT Bombay and Semiconductor Complex have resolved. They developed a process technology that is for the memory devices using a particular oxidation process. That was a very good thing, and actually it's excellent. But if you look at the production capability of SCL, it is nowhere there. They cannot provide chips. Right now, there is a big chip shortage world over, and that is because of supply chain as well as manufacturing processes. And if that is all the chips will go directed towards United States and Europe, then India's share will be very low in that process. And we don't have, SCL is not producing chips for the internal market in a massive way. They have a good technology. They are developing a lot of prototypes for different companies and different groups, but I don't think they are producing chips in a massive way to supply to the Indian market. So that they're like, and 180 nanometers was in 90s technology in United States. Yeah. I worked in Bell Labs in the 90s technology. So if you talk about 2021, we have a breakthrough in some of the processes. That is actually very good still, because that will have some advantages. But we got to think about, can we make the processors there, the advanced processors, so that we can build the supercomputer in that. So that type of lab, if the Tatas will invest, which I saw the news also, they can collaborate with one of these technology. We have a tremendous manpower. People know this. And so I am involved with ISC Bangalore also, with the group. They were trying to build something like IMEC, a facility like that. So Mayank Srivastav is leading that one. So I try to put some of the companies in the United States to put them in connection so that they can have some partnership with there. But it is nowhere there to compete with anyone else around the world. So that actually everybody, those who are working in supercomputer should push for that. Those who are working in the technology or chips or equipment manufacturing, they should also push that we need to have our the silicon fabs so that it will supply our chips, indigenous chips, to in India's consumption. That's all I can say.
Okay. Thank you very much for sharing your views, sir. So are there any more questions to Ajay ji? Okay.
So, one final comment is nobody is going to come and solve our problem, Satyaji.
Yes, of course. Yeah. So with that nice, I think rather thought-provoking line, and basically saying, indigenous developments are something which are going to put you through, not just by let us say, importing or...
Actually, we'll be very happy, Satyaji, to give another talk at some point on the
Sure.
catalyst proposition. It should be a worldwide collaboration, and India taking the lead. I mean, I'm proposing that to the National Research Foundation. Thank you.
Okay. Thank you once again. Thank you very much, Professor Datar, and also thank you, Ajay ji. Thank you, Durga Mishra ji, also for actively participating and sharing your views on it. So with that, I take leave and I wish you all a safe weekend and enjoy. Thank you. Good night.